We're going to look at trigonometric functions in a new light now. Let's say we have some point a comma b that's anywhere on the coordinate plane, and then have a line going from the origin through a comma b. We can define the trig functions of this angle created between the positive x-axis and this line we're describing in terms of the x and y values and the distance between the origin and that point. This r, in this case, is basically the distance because it is the square root of a squared plus b squared. Now, given that information, we say that the sine of theta is b over r, or you might say it's the y part of the point over the distance r. Cosine is going to be the x part of the point divided by the radius. Tangent is going to be the y part of the point divided by the x, and so forth. Let's find the values for the trig functions given a point. For example, if we have the angle where the terminal side is going through the point -6, 4, so that gives us this angle, theta. What are the trig functions? Well, sine theta is b over r, and let's see, we've got our a is 6, our b is 4, but what's the r? We'll use our Pythagorean theorem to find that. R is the square root of -6 squared is 36, 4 squared is 16, so r is the square root of 52, which is 2 times the square root of 13. When we pull the 4 out, we end up with 2 square root of 13. So sine theta is going to be 4 over 2 square root of 13, which simplifies to 2 square root of 13 over 13. Cosine theta will be -6 divided by 2 square root of 13, which simplifies to -3 square root of 13 over 13. Tangent theta equals, that'll be our y value divided by our x value, 4 over -6, which reduces to -2/3. For cosecant theta, we can go to the reciprocal of sine, so that'll be the square root of 13 over 2. And secant theta will be the reciprocal of cosine, so that will be 2 square root of 13 over -6, which is -square root of 13 over 3. Again, I take this value, the reciprocal of 2 square root of 13 over -6, divide out my 2's, and I get -square root of 13 over 3. And finally, cotangent of theta is going to be the reciprocal of tangent, -6 over 4, which is -3/2. Notice I have no idea what this angle is, and I don't really care. I can tell you that it is greater than 90, because this is 90 degrees. This is 180 degrees, so it's somewhere between 90 and 180. But I really don't care anything about the angle. Once I have the point, I can get all my definitions from that. Another thing I'll point out, just because it may seem a little odd, is if you have an angle that is between 90 and 180, you would write it as 90 degrees is less than theta is less than 180. Essentially, that's telling you that you are in the second quadrant.